Welcome to RectSpace. In this video, we will learn about one of the most important concepts in calculus, limits. Whether you are just starting out with calculus or need a refresher on limits, our aim is to give you a solid understanding of what are limits. So, let's jump right in. So, what are limits? Limit is a way of describing how a function behaves as it approaches a certain point. But it's not necessarily about what the function equals at that point. It's about what the function is approaching as the input gets closer to that value. If a function f(x) gets closer to L when x gets closer to a from both sides, the limit of the function is said to be L. Mathematically, it is written as limit of f(x) as x tends to a equals L. Let's take an example. This graph has a hole at x equals 6 and the actual value of the function at x equals 6 is 7. Now, the question is, what is the limit of the function as x approaches 6? In order to find the limit as x approaches 6, let's start from any point on the left side and move towards 6 along the x-axis and observe the y value. Notice that as x approaches 6 from the left side, the y keeps on decreasing and trying to reach the value 4. Now, let's move towards 6 from right side and observe the value of y. Notice that y value is getting closer to 4 as x goes closer to 6 from the right side. Since y value is getting closer to 4 as x gets closer to 6 from both sides, the limit of the function as x approaches 6 is 4. From this example, we saw that the limit of a function at a point may not be the actual value of the function at that point. Now, let's discuss about different types of limits. The first one is left-handed limit. Notice the negative sign over a. This represents the limit of the function as x gets closer to the point a from left side. The second one is right-handed limit. Notice the positive sign over a. This represents the limit of the function as x gets closer to the point a from right side. The third one is the normal limit. This limit exists if both left-handed and right-handed limits are equal. If both the limits are different, this will not exist. Now, let's take an example to understand these limits. Consider the following graph of a function. Let's check what will be the values of these limits as x gets closer to 6. Let's check what happens as we move towards x equals 6 from the left side. Since y gets closer to 9 as we move from left side of 6 along x-axis, the left-hand limit of the function as x gets closer to 6 is 9. Let's check what happens as we move towards x equals 6 from the right side. The y gets closer to 9 as we move from right side of 6 along x-axis. So, the right-hand limit of the function as x gets closer to 6 is 9. Since both left-hand and right-hand limits are 9, the normal limit of the function as x gets closer to 6 is 9. Let's check what will be the values of these limits as x gets closer to 12. Let's check what happens as we move towards x equals 12 from the left side. Since y gets closer to 6 as we move from left side of 12 along x-axis, the left-hand limit of the function as x gets closer to 12 is 6. Let's check what happens as we move towards x equals 12 from the right side. The y gets closer to 1 as we move from right side of 12 along x-axis. So, the right-hand limit of the function as x gets closer to 12 is 1. Since both left-hand and right-hand limits are not equal, The normal limit of the function as x gets closer to 12 does not exist. Thanks for watching. If you found this video helpful, don't forget to like and subscribe for more clear and concise lessons. Got questions or suggestions for future topics? Drop them in the comments below. I'd love to hear from you. See you in the next one.